All right, in chapter 4, we'll be talking about quadratics. Today in section 4.1, we're going to be starting to graph quadratics. Graphing quadratic functions. Hopefully you recall from an earlier unit when we talked about transformations that when you graph a quadratic, we get a parabola. A quadratic has an x squared in there. Everything we've done prior to this chapter was linear. So it had like an x, now we get into x squared. We are going to be focusing today on like the standard form of a quadratic function, which is this. F of x is equal to a x squared plus bx plus c. I want to highlight the a, the b, the c. Those will be coefficients, so they'll be numbers. A and b are coefficients, c is a constant, but we'll replace those with numbers once we know what a is, what b is, and what c is. But I want you to be familiar with the fact that when I refer to a, I'm talking about the coefficient of the x squared, the quadratic term. When I talk about b, it's the coefficient of the linear term or the x term, and then c is your constant. And we're going to be graphing these. We know it's a parabola. Just a reminder that with a parabola, there will be a vertex. And we would, when we graph these parabolas, we would like to identify that vertex for a couple of reasons. If I ended up just getting a few points, think about something like this. You don't have to write this down, but just like if I gave you a few points like this, does that appear that maybe they're a part of a quadratic? Yeah, but if I asked you to graph it, we might not know. Actually, I probably gave more information there than we could, but what if I stopped it like right there? Clearly, they might be part of a quadratic, but I don't necessarily know exactly where the vertex is and where to come back up. It wasn't enough information. So that's why it's going to be important when we graph that we know where the vertex is so we know where to change directions. But additionally, we know a parabola is symmetric. So if you think about reflections in geometry, we know that a parabola is a reflection. The two halves are reflections of one another. So if you get one side of the parabola, you can reflect it across to get the other side. That's an axis of symmetry. Those are pretty important pieces when I go to graph a parabola. That axis of symmetry, in this case, it's a vertical line. Is that always going to be the case for an axis of symmetry on a parabola? Yeah, it is, unless I go for the inverse function, which we're not talking about right now. So it'll be a vertical line. Remember that a vertical line has an equation, x equals. Y equals is a horizontal line, x equals is a vertical line. There is a little formula. I'm not going to derive it right now. Later in the chapter, we'll see where this came from. But for now, I'm just going to tell you that this equation, this is important to know, x equals negative b over 2a. And that b and that a are referring to the a and the b that I have underlined on the left. We will want to find that. It's probably going to be the first piece of information we find when I go to graph something. And then once we know that, we know that the vertex is on the axis of symmetry, and the vertex is an ordered pair. Which of the two numbers of the vertex do I know at that point? Well, we know the vertex is on the axis of symmetry, which has the equation or the rule that x is equal to negative b over 2a. Therefore, the x has to be negative b over 2a. We know that will always be the case of the vertex. And then we have to find the y-coordinate. How do we find the y-coordinate? Well, we'll have to take that value, we'll have to plug it into the equation in place of the x. And there's two places that x goes up. We have the x squared term, we have the x term. You'll have to plug in both of those places and evaluate to figure out what the y coordinate is. So over here, I would say, oops, trying to get my eraser, there we go. I would say, how do we get the y? You plug it in. I don't know if Glade plugins is still a thing, and if they have commercials, probably certainly don't advertise on Netflix, so you guys probably don't even see commercials anyway, but their little slogan or whatever was a little ditty, plug it in, plug it in. So it's kind of the same idea here. We're going to Glade plugins. We're gonna take the x value, we're going to plug it in to figure out what the y coordinate is. So we're gonna go ahead and jump into a problem. We're going to graph. We'll go through that process. Here we go. We'll leave right there. Okay, so let's graph this equation. F of x is equal to 4x squared minus 8x plus 1. Before I graph this, that a value here is a positive 4. We know from our transformations discussion before that our quadratics looked a little different than this, but the a value works the same. If the a value is 4, what does that tell us about our function? Do you recall what's going to happen? Is it reflected? Yes or no? Excuse me, yes or no? Is it stretched or compressed? Well, is this one reflected across the x-axis? No, the only way it would be reflected across the x-axis is if I gave the a value a negative, like if I made it negative 4. I'm going to take it away here. It's not negative, so this one's not reflected. But is this stretched or is this compressed? Do you recall? Hopefully you recall. We've been tested on it before. But you look at that a value, and if it's larger than 1, it's stretched. Our a value is 4, so we do know this one's going to be stretched. I'm not asking that question right now, but you should know that from a previous unit. So here's what I'm going to find first. My axis of symmetry, I'm going to abbreviate that AOS. X equals, and I'm going to use the formula that I have over on the far right corner of the screen. Negative b over 2a. So negative b. Well, b is a negative 8. So I actually have a negative 8 over 2 times a being 4. So a negative 8, the double negative becomes positive 8 in the top, and then in the denominator 2 times 4, that's 8. So we have 8 divided by 8, which is 1. I'm going to put that on my graph real quick. But what I know it's x equals 1. It's a vertical line. But it's not really part of the graph. It's just that line of reflection, that line of symmetry, cuts it in half. So I'm going to make it a dashed line. It's helpful to see it when I go to graph, and I will use that to my advantage. But let's go back over here. I know the vertex has that number 1 as its x coordinate. Don't know what the y coordinate is yet, but I know it's x coordinate. And then actually I'm gonna do a little double duty here. I'm gonna make an xy table, and I want that vertex to be in the middle of the table because I know it's symmetric around there. So whatever, that 1 is going to go right in the middle, and then I'll probably pick numbers larger and smaller. So 2 and 3 and 0 and negative 1. But let's plug in that 1 first and see what the vertex is. So you plug 1 in place of the x. So off to the side here, 4 times 1 squared minus 8 times 1 plus 1. Well, 1 squared. Please do order of operations first. Square before you multiply. 1 squared is 1 times 4 is 4. 4 minus 8 plus 1. Well, 4 minus 8 is negative 4. Plus 1 is negative 3. So 1, negative 3 is the vertex. That's where my parabola is going to hit that graph. And then we're going to plug in other numbers. 0 is easy to plug in. I actually really like plugging in 0. And if I'm choosing 0 for an x value, where is that point going to show up on the graph every single time? Anytime I use an x value of 0, it's going to be on the y-axis. We're actually finding the y-intercept. That's good to know. I might actually come back up over here off to the right and jot that down. The y-intercept is what you get when you plug in 0. And if I look at the general equation up above in green, if I plug 0 in for x there and there, what am I left with? Just the c, whatever the constant is. So that c is always going to be your y-intercept. That's a very easy point to get. So, and when I plug it into this particular example, my c was a positive 1. So when I plug in 0, I get 1. But because I know things are symmetric, that 1 should show up in another spot. Where should it show up? Should show up with the 2 because it's symmetric. Let's make sure. It's always a good idea just to check and make sure that we didn't make a mistake. Because if we made a mistake, then we got to fix that right away. So plug in 2 just to verify that also works. Sorry, got a little messy there. 2 squared is 4. 4 times 4 is 16. Minus 16 plus 1. Oh, it does in fact equal 1. Good. So it is balanced. So we are surrounding our axis of symmetry. So 0, 1, and 2, 1 both hit. And if I had just those 3 points right there, I probably could sketch the parabola, but we want to go with 5 points just to a little bit of security and make sure we did it right. So that's why I've chosen 5 points instead of just 3. So we have one more pair to plug in. -1 and 3 should give us the same answers as long as it's really symmetric. So we plug in order of operations. You have to square. Did I make a mistake somewhere? Oh, it is on 0, 0. Thank you. Both of those points were wrong, weren't they? Ooh, that's a really big eraser. Okay, so I had, sorry, the point 0, 1, thank you, and 2, 1. All right, good. So let's come back over here. We were plugging in -1. Order of operations. Square -1, you get +1. So 4 times +1 is 4. -8 times -1 is +8. +1, so we get a total of 13. That's when I plugged in -1. Should give us the same thing when I plug in 3. That's going to be off the graph. I can plug in 3 just to make sure that I didn't make any mistakes. So 3 squared is 9 times 4 is 36. Minus 24, so we're at 12 now. Add 1, we get 13. Yes, so it is balanced. So 1, 2, 3. I should change colors. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's the advantage to being on a grid, but on your notes, you might struggle to get those points in. You may notice that as I graph this, I did one side of it first. I always do this. I always start at the vertex and go one side and then the vertex the other side. I recommend doing the same because remember this is a parabola. It's a U shape, not a V. You should not, if you zoom in to your vertex, zoom way in, it really should not be a point. It should be curved, even right there. So do your best to draw it so we don't get into a point. Now, I'm not going to zoom in on yours, but understand it should not be a point, a sharp point. Question was, will you be provided these formulas? And I'm assuming we're talking about these right there. The answer is no. So no, really the only thing you need to know is negative b over 2a. You won't be given the standard form either. That's pretty easy to remember. Your x squared term, we call this descending order. Your largest exponent first, x squared, and then just your x, and then your constant, and then the coefficients were in alphabetical order, A, B, C. Now, the other piece of this that you'll be asked sometimes on the assignment, they might ask about max and minimum value, the maximum and minimum value, and domain and range. So, look at this particular problem. If they ask about maximum and minimum value, first of all, do you suppose that they're talking about the x value, the left-right value, or the y value, the up and down value? If they're asking about like the maximum or the minimum. Any guesses? The y value, the height of it. When they ask about the maximum minimum value, they are talking about the y, or in this case, actually an f of x value. If you look at this picture, is there a maximum value? Is there a top to the graph? It looks like arrows to me that keep on going. If there's arrows that keep going, it doesn't stop. There's no maximum. Is there a minimum value? Yes, it comes down until you get to the point. The vertex, yes. And specifically, the height of it, the y-coordinate of the vertex, was the -3. That was the minimum value. So if you're asked about a max or a min value, this particular one has a minimum value. And that minimum value, here, I'll do it this way, was -3. Now, could we have anticipated before I ever graphed it, just looking at the equation itself, how can you tell if that's going to be a minimum or a maximum value? What does this value tell us about the graph? It's stretched, but it also is positive, so I know that my graph was going to open up. I knew that it was going to be, I didn't know any specifics at that point, but I knew it was going to be a parabola opening up. Therefore, the vertex was at the bottom, not the top. So right away, we should be able to determine whether it's going to be a maximum or a minimum value. And then once you find your vertex, the y portion of your vertex is the max or min value. So this one we knew had a minimum at -3. Additionally, domain and range, which I'll usually just abbreviate as D and R. We've done a little bit of domain and range discussion in the past, but domain is what x values were we allowed to plug in. So look back at the original equation. Whatever your x is, you're going to square it, multiply by 4, and then you're going to multiply by 8 and subtract that away, and then you add 1. Is there any limit or restriction on what I could plug in for an x value? No, all of them are okay. So how would I answer that? I would say all real numbers. You can write that out, or there's a symbol for real numbers, like this. Looks like a capital R with an extra vertical bar. You're welcome to use that symbol for all real numbers, or if you want to write all real numbers, you may. Do you think that's unique to this particular parabola, or do you think that's going to be true of all parabolas? It will be true for all parabolas. Eventually, in other units, we will get things that are not parabolas and their domain might be restricted, but this is a case where the domain is always going to be all reals. What about the range? That's now the y values, the height. It does go up forever. This particular one goes up forever, but did it go down forever? No, this sounds like a similar conversation that we just had regarding the minimum. It's very much tied into that. The graph, the lowest point was -3, which means we were able to graph above -3 and -3 itself, but nothing below. So y, or technically we're not using y here, we used f of x. I wouldn't care if you used a y there, but I'm just trying to be consistent with the problem that was given to us. That value was greater than or equal to -3. So there's my domain and range. Those will be asked on the test, yes. All right, and that should be sufficient notes to be able to work your way through for one. This is not the only graphing we're doing. This is just the only graphing we're doing in this section. It will continue with more graphing tomorrow.